The next operator that we're going to have a look at is the complement operator, the ones complement operator, often just called the tilde or squiggle, or depending on how you like to pronounce that particular character. I personally call it the tilde operator. The tilde operator does the following. It's a unary operator, so it only works on one number. It simply sits to the left of that number, just like the minus sign, like -4. We'll have tilde 4. And all it does, it reverses each bit in the bit pattern, producing the ones complement of that number. If you know what the ones complement means. If you don't worry about it. But it just simply turns all the bits that are 0 to 1 and all the bits that are 1 to 0. It's very, very simple. And here's an example. If we use an 8-bit number, this is what we would get. Tilde of 211, or the ones complement of 211, equals 44. Now again, I've got to stress, that's using 8-bit numbers. If we use 32-bit numbers, then the ones complement of 211 would be a very vast number. It would be about 4 billion minus 44. Let's have a look at why those two numbers happen to be what they are. 211 as an 8-bit number is 11010011. 44 as an 8-bit number is 00101100. In fact, it's exactly the opposite. All the bits that were 0 are 1 and all the bits that were 1 are 0. So as you can see, it's a very, very simple operator. And incidentally, 211 plus 44 just happens to be equal to 255, which is the largest number you can represent with 8 bits. Let's go and have a look now at the coding example of the tilde operator. Here is complement.c, which I'm going to use to demonstrate the ones complement operator. And again, same sort of thing. We've got a number and a result, and we enter a number, we take the ones complement of that number, and we get the result, which we'll demonstrate in both hex and in decimal. Okay, let's compile that. It's very, very simple. Please enter a number. We'll try that example from before, 211, and the ones complement of that is 44. If we try it the other way, theoretically, the ones complement of 44 should be 211, and it is. Now, all of that is using 8-bit numbers. These are unsigned chars here. Remember, a char is 8 bits and only 8 bits. I can change this from a char to a long, and I can change this to a long, and we could run it all again and get different numbers. And now, if we enter 211 and get the ones complement of that, we get a very, very large number. Like I said, it's about 4 billion minus 211. And there it is, FFFFFF2C, if you happen to know what hex means. The largest number that you can represent with a long or a 4-byte integer is FFFFFFF, or 1111111111, 32 ones in binary arithmetic. Anyway, there's a little demonstration of the ones complement operator.